Welcome back. In this video we're going to be going over momentum, physics worksheet number 1, number 2, problem number 2. In a freight yard, a train is being put together from freight cars. An empty freight car coasting at 10 meters per second strikes a loaded one that's stationary. The cars couple together. Each one of the cars has a mass of 3,000 kilograms when empty, and a loaded car contains an extra amount of 12,000 kilograms of canned soda, which apparently is a year's supply of the physics class. With what speed does the combination of the two cars start to move? Because they couple together afterwards, it says, and so how fast are they moving afterwards? Okay, so I'm going to approach this the same way as always. First, I always look at the action here, and this action right here is that they're striking together and then they couple together, which is kind of like the same action there. So maybe all of that's the action. So I'm going to do a before and after of that right there. So here's my before and after. So before and my after. And so we have two train cars here, and we'll do simple train cars. And they have some sort of like coupling device there. And this other one, the coupling device, looks a little bit different than that, but from the side view you can't actually see how the couple would be. It'd only be from the top view that you can actually see that coupling there. So this is the empty one, so we'll say this is empty, label it that way anyways, and it's going at an initial velocity of 10 meters per second. And this guy then has 0 meters per second. It's not moving at all. Now I'm going to, for ease here, I'm going to label them as this is cart 1 and this is cart 2. Maybe I should do A and B since we're going to have numbers with this and that might get confusing. So A and B. Each one of the cars has a mass of 3,000 kilograms and empty, and the loaded car, so now it coasts and it strikes that loaded car here. So let's go ahead and let's put the masses down. So the mass of B, isn't that nice? That's an easy way to do that. Is now, what is it? Is it 12,000 kilograms for the mass of B? Well, careful. The loaded car contains 12,000 kilograms of soda, but then it's also got its empty weight there as well. So it's going to be 12,000 plus 3,000, and we get a total of 15,000 kilograms for its mass there. And so then the mass of A is pretty simple. That's just 3,000 kilograms. And I look at the unit and go, kilograms. That's the standard unit, so I'm all okay there. Now let's draw the after picture. After picture, these guys then couple with one another. So these guys are like coupled together. So now whatever speed A has, let's go label them as well. Whatever speed A has, B is going to have the same speed and vice versa. So now it's really just one velocity, and we're not sure what that velocity is. Now we know the mass of each of these guys because the mass isn't going to be changing of each one individually there. So, okay, great. Well, what are we going to make our system? Well, you can make your system, each one independently, or just one of these independently. But for most of these cases, I think it's easiest to make your system everything that's moving here. So I'm going to make my system both A and B, or both of the carts, you might say. And so then I know that if I am including everything that's actually transferring motion between the system, that the total change in momentum then must be 0. Another way to write that is the beginning momentum must be equal to the ending momentum. What's the beginning momentum in this case? Well, it's the momentum of A plus the momentum of B, and these are the ones at the beginning here. And then that's got to be equal to the momentum of A afterwards and the momentum of B afterwards. Now that's true. Oh gosh, that's like a capital P. Not that it really matters. Now that's true. However, I can think about this in a slightly different way. Yes, A has a momentum and B has a momentum, but in this case, I could also think about it as A and B are one thing since they're connected to each other and they got to be moving with one another. So I'm going to think about it like that because I think that's a little bit easier, but it's really, you can do it either way. So now if, let's fill that in on the left side there then as well. We know the momentum of A there. It's just its mass times its velocity at the beginning, velocity of A at the beginning. Plus, we know that this guy is going to be 0. Well, maybe I'll write it out. It's the mass of B times the velocity of B at the beginning. But we know that this velocity right here is 0, so then that whole term becomes 0. And let's think of what we know on the other side here. Well, this is the mass of A and B times the velocity of A, B, and clearly that's afterwards. Well, let's think about that. Do we know the velocity, or the mass, sorry, of A and B? Well, clearly it's just got to be the mass of A plus the mass of B there. And so then that thing has got to be 15 plus 3, so that's 18,000 kilograms. Oh, well, that's cool. So let's put in everything that we do know and see if we can go and solve this. So I know that this guy, this mass over here is 18,000, and I'll drop the units just for clarity's sake here, so we can just focus on the numbers. I oftentimes do that for just when I'm doing the work myself. If I already know that they're all standard units, then I know that all the units are going to work out just nicely anyways. The mass of A was 3,000, if I recall correctly, and the velocity was 10 meters per second. And in the picture here, I had it going to the right-hand side, so that'd be a positive 10. I'm just making sure. I'm always double-checking my signs and such. Now I look at this and I go, hey, how many variables do I have? I only have one. That's the velocity of AB. It's the only variable I have. Maybe, I could get fancy here and highlight that in pink or red or something. Yeah, so that's the only velocity, the only thing that I don't know. And so now I can just go and solve for that. So let's pick up our calculator and calculate that. So on the left-hand side, that becomes 30,000 divided by 18,000. And I get a velocity of AB is 1.6 repeating there, so 1 2/3 meters per second. And I think about that, and it came out to be a positive value, and I look back at the original problem and go, well, that makes sense. I got one thing moving to the right, the other one's not moving. Now they're moving together to the right. Yeah, because the one's going to shove the other, and they're going to kind of be moving. And they're going to be moving slower than just the one by itself. And that's exactly what we found. We found that it's going to be moving a lot slower. And I think about the proportions there as well. I go, okay, the light thing hit the heavy thing, and when it hit that heavy thing, it got the heavy thing moving. Well, the heavy thing shouldn't be moving as fast, and it's not moving as fast. And since it's a lot heavier, the 15,000 kilograms for that thing that wasn't moving, it's a lot heavier. It should decrease, the light thing should decrease its speed by a good amount. And it goes from 10 down to 1.6. That's a good amount. So almost kind of double checking myself with proportions there. That's it. Have a great day.